I want to look more towards the final stage of the design process. We actually have to manufacture those components and put them into production. Now, one of the things that we've really found, at least in MLC, is that a lot of our customers are getting into additive manufacturing or 3D printing. Now, we looked at a lot of technology. We tried out a couple different companies, and the one that we really kind of landed on that we thought had the coolest, most useful technology was obviously Markforged. Now, Markforged introduced their desktop line of printers several years ago, and they kind of changed the game because they allowed us to actually print continuous fiber reinforcement. So stuff like Kevlar, carbon fiber, fiberglass. Basically what that meant is you could make really, really strong parts. Parts that you could print, put into production, they're not going to break. They can actually serve a purpose. They don't just look pretty sitting on a table. Now, after their desktop line, they came out with their industrial line. This was basically bigger and badder, right? Stronger parts, larger parts, more accurate parts, additional material support. And recently, they've kind of changed the game again, and they've introduced the Metal X. So we've actually got a couple parts up here, but the Metal X is basically a metal printer that can do all sorts of cool stuff, and it doesn't necessarily adhere to the typical metal printing design standards. One of the really cool things that they do is they actually encapsulate that metal powder that gets printed out in wax. So if you've ever been around a metal printer that kind of has all that powder, if it's not contained in wax, it can get everywhere, it can make a mess, it can be an irritant. But with Markforged, they actually capture it in wax. That wax melts away, and then we center that part to get it really, really strong. We can put those parts into production. We've got several different material types. I am not part of the printer team. I like to just waste their time and print cool stuff. But the printer team, they've got a lot of cool parts up here. So if you haven't talked to Kyle, if you haven't talked to Travis, if you haven't talked to the Markforged guys up here, come check it out. We've got a bunch of these different parts and also different material types. Jeremy's big on the copper. I don't get it. EEs are weird, but we'll let him have it. But a bunch of cool things, so be sure to check that out. If you want to learn more, another really cool resource is our YouTube page. So we've worked really hard to put up a lot of videos on YouTube. We want to make it easier for you guys to find this information, consume it, share it with other people. And one of the things we've done is we've got a whole video series on the Metal X and all the other Markforged printers. So if you leave and maybe you forgot about kind of what it was you saw at the show or you want to share it with somebody, check out our YouTube page. It's got a lot of cool videos. And we also put a lot of information about SolidWorks up here. So things like how-tos, whether it's installation instructions or part modeling questions. We're also going to put a lot of what's new content up there as well. So you may have seen Marcus run around with his camera. Basically what we're going to do is we're going to put up some of these videos. So months from now, if you want to kind of revisit when you guys go to upgrade because your company's a little behind, you can go check out these videos, see those features, and start using them right away. Our YouTube channel, it's MLC CAD Systems, so search for us on YouTube, and then if you want to subscribe, you can. We put out videos weekly, lots of cool content. Now, speaking of 3D printing, SolidWorks actually has some pretty cool 3D printing tools as well. How many of you guys have 3D printers or access to a 3D printer? Pretty much everybody. So if you're not aware, inside of SolidWorks, let's pretend that we wanted to print this part off the Omax water jet. I can go up to File, Print 3D, and we've actually got a whole 3D printing menu here that can help you guys either set up a print or maybe just evaluate your part for printing. And this is really what I like to use it for. Our Markforged printers, they have their own client software called Eiger. Works really well, got a lot of really cool features. But I can basically do a little preliminary work inside of SolidWorks to just kind of make sure that this part I've built can actually be printed. So in 2020, the first thing we've got is the ability to manage favorite printers. So if I click on Manage Favorites, I've got a whole list of different printer manufacturers, and I can go search for the one that I want to use. I'll grab my Mark II that we have in Dallas, and I'll hit Add to Favorites. Once I've got that printer, I can basically start to do a little bit of setup work. So the first thing I'm going to do is I'm going to select a plane that I want to use as basically the bottom plane of my model. As soon as I do that, you'll see that it basically shows me the bounding box for my component. Now, immediately, I can basically see that I've got a couple tabs that are actually sticking out of that bounding box, right? So I need to make sure that I can actually fit that part in the bounding box. I could manually start to offset this geometry to try to get to fit. I already mentioned I'm a little bit lazy, so I'm going to choose Orient to Fit. We'll let SolidWorks do it for me. Now that I know my part can actually fit, what we're going to do is we're going to go over the Preview tab. Now, the Preview tab can let me see a little bit more about the actual process of setting up this print. So the first thing that I want to see is just show me what faces are going to require support. Here I'll check that button, and you can see that all these green faces are actually going to require support material. This is important because sometimes faces that require support, they don't always wind up with the best surface finish. So maybe if I've got a surface that really, really needs to be smooth, we want to just evaluate the orientation, make sure that's not going to be a support face. I can also choose to see striation lines. So if I want to see kind of layer by layer how this part's going to be built, I can see a graphical representation of those striation lines, or I can choose a new option called preview slices. What's cool about preview slices, it's not just a graphical layover of all of my lines. It's actually physically cutting up my SolidWorks model. This isn't a mesh file. This isn't an STL. It's actually layering this whole thing. I like to use this to go analyze really small features like this bolt hole. I want to make sure this thing's going to be a circle, not a hexagon, so I can see exactly how many layers are going to go through that. Once I've evaluated my part for printing, what I can do is I can go up to File, and I'm going to choose to save this out. Now, a lot of you guys are probably using STLs, and we use those quite a bit as well, but another file format that's really popular is 3MF. With a 3MF in SolidWorks, you can actually save out that file, but you can also include some additional information. So one of the big things here is the ability to include materials. You can include appearances or textures, or you can also include all of that slice data that we actually generated earlier. So if you guys have access to printers, or you're currently printing stuff in-house, be sure to check this out. If you're like me, I just use it as a little setup, little sanity check, make sure I can print that part, it's going to fit in my printer, and then I can send that over to my printer team. Now, how many of you guys work with large assemblies? Relatively large assemblies. A couple hundred parts, maybe a couple thousand parts, right? Now, large assemblies are really good. Some of the challenges that we see with large assemblies are where we get to the drawing stages. So with our drawings, if you've got a large part or a large assembly that you're trying to open up in a drawing, that drawing can sometimes take a little while to open. Maybe it's 10, 20 seconds, maybe it's a couple minutes, but at the end of the day, it can sometimes be a little slow. What I want to show you guys is a new option for opening large drawings that should help you actually work with those a little bit faster. Now you can actually do this from File Open, or you can do it from recent documents like I'm going to do. This new mode is actually called detailing mode. So you guys are probably familiar with quick view, lightweight, fully resolved, but now the new one is called detailing mode. When you open up a drawing in detailing mode, what I'm going to open up here is that Omax water jet. It's about 5,000 parts. I want you guys to just watch and see how long it takes to open up this drawing. All right, that's it. Okay. So a 5,000 part assembly in a, 6 or 7 sheet drawing took me 10 seconds maybe. Pretty quick. Now, I know what you guys are kind of saying, well, we've had quick view for a while. Quick view could pretty much do the same thing. So what's different about detailing mode? I want to walk you guys through a couple of different scenarios. Maybe I'm kind of reviewing a drawing. Roland made this drawing, and I'm fixing to go and make sure that it's ready for actually sending it out to the shop floor, make sure everything looks good. Now, I noticed right off the bat, Roland forgot to move this balloon around. He does that sometimes. You know, he probably got busy grabbing a beer out of the fridge or something at work. So I'm going to go ahead and drag that balloon back over, and I'm just going to snap it to a magnetic line. Not a big deal. Let's move over to the next sheet. This might have been Jeremy's sheet. Sometimes Jeremy, he doesn't want to make multiple sheets. He just throws a whole bunch of views onto one sheet. So I'm going to kind of do a little cleanup work here. Maybe I'm going to start off by seeing if I can rearrange these views. Looks like we don't really have a whole lot of room, so I'm actually going to try and move one of these views to another sheet. So I'm going to go ahead and copy this, this view that we've got here, and then I'm going to go ahead and add a brand new sheet. I'll choose my sheet format, and then we're just going to go ahead and paste this onto a new sheet. Okay? All right, pretty cool. So we can move balloons around, we can copy and paste some views, so we can definitely do a little bit of cleanup work. Maybe we'll go look at this bill of materials page. At first glance, this looks pretty good, but actually notice I'm missing an item number. So let's see if we can actually update this bill of materials in this annotated view and add another balloon. So we'll go ahead and attach it to this item here, drop it down, and sure enough, SOLIDWORKS is still able to pick up the item number. So we know that we're actually working with a little bit of parametric data. There's some intelligence in the background. We can pick up on the info in our BOM. But I already know the question all of you guys are asking, can I actually add dimensions? Can I do some real work in here? And the answer to that is actually yes. So if I grab my Smart Dimension tool, I can actually go in here in detailing mode, and I can dimension the size of different features. I can dimension distances between faces. You can basically do all of your standard detailing, or at least most of it. If you guys go ahead and look up at the annotations toolbar right now in the command manager, you'll notice that most of the objects are bold. A few of them are grayed out. Those grayed out items are the ones that you cannot do in detailing mode. But if you're looking for a way to just finish out that drawing, get all of your annotations on there, you can add dimensions, notes, you can do balloons, you can do surface finishes, weld symbols, GD&T annotations. You can do probably 80% of what you need to do. So if you guys are working with those large drawings, what I would encourage you to do is maybe start out fully resolved, add several of your views on there, save it out, switch to detailing mode, and then you can work really, really quick. Should help you guys get through that final stage of the design process. Everything you do in detailing mode when you save it, it will appear when you open the drawing lightweight, fully resolved, or in quick view. So none of the work here is lost. It's all going to get saved in the document. You can even go and save this out to a PDF or eDrawings file if you want. It's got a lot of your standard drawing functionality. So if there's one thing that I would like you to remember from at least my presentation, that's probably my favorite feature right there is detailing mode. Now, drawings are really great, but we've got a lot of customers that are trying to move to a drawingless environment, right? They're looking to maybe manage all their data with one less file format to keep track of. One of the ways that we can do that is through a product called MBD. So SOLIDWORKS MBD stands for Model-Based Definition, and it allows you to put all of your manufacturing info directly on the 3D model. So instead of having that 2D drawing that you have to manage and update, you put all of your dimensions and annotations right on the 3D model and you manage it there. So with MBD, kind of the idea is that you create these 3D views. So I can create my front, right views, top views, and I can attach data to each view. In 2020, we've added a couple of enhancements. So up here on my annotations folder, I've got my front, top, and right view that you guys just saw. But in 2020, if I expand one of those views, you'll actually see every single dimension or annotation that is attached to that view listed in a folder structure there. So that basically makes it a little easier just to see what dimension is on what view. Kind of a small change, but it does make it a little bit easier to digest. The big thing that I like is that these are all DimExpert dimensions. If you guys have used DimExpert dimensions in the past, they kind of had a funky naming convention, maybe a little bit hard to understand. So in 2020, they actually follow the same naming convention as your Smart Dimension features. So you'll notice that it's basically named the dimension type at the feature name and then the value of the dimension. So it makes it a little bit easier to actually get some useful information out of the name of that dimension. If you would prefer to maybe organize your annotations a little bit differently, one of the ways you can do it is you can actually do it by sorting through annotation type. So if you don't want to see it listed out by annotation view, you can sort it by annotation type, and you can basically see dimensions, GD&T annotations, datums. You can sort it all out there. So a couple of small enhancements for MBD. If you guys are looking to go to a drawingless environment, I encourage you to check this out. We've seen a lot of customers do it to save time and organization. A lot of people are also trying to adhere to DoD standards where they're basically prioritizing some contracts if people can adhere to drawingless environments. From here, what we would do is we would basically share this with other SOLIDWORKS users, or we could actually save out a 3D PDF. You can send a 3D PDF to anybody that's got Adobe Reader, which is free, and they can open this up, spin the model around in a PDF. Really, really cool. Another way that we really share information is through SOLIDWORKS Composer. How many of you guys are involved with making any sort of technical documentation, assembly instructions, user manuals, anything like that, right? If you don't have a dedicated tool for it, and trust me, I've been this guy. I used to have a real job. I was an MLC customer. I used to have to sit there and take screenshots of SOLIDWORKS, and I would give it over to my marketing team, right? And say, hey, we want this. We want to put up on the website. I'm like, all right, let me grab a screenshot. I'll send it over to you. We've actually got a tool that's a little better for this. It's called SOLIDWORKS Composer. Been around for quite a while now, if you haven't seen it. So what I want to show you guys is just one of the ways that SOLIDWORKS Composer has been enhanced for 2020. As engineers, what we normally do is we go in here and we make all sorts of saved views, and we also make a lot of exploded views, right? Now, the tricky part was in the past, you would make all these views, but when it came time to actually work in Composer, you'd have to recreate all these views again. Your exploded views and your saved views, they actually didn't import into Composer. In 2020, inside of Composer, when you go to import a SOLIDWORKS assembly, you'll actually see that you've got the option to import all of your exploded views and your saved views. Okay, so this is going to save you a little bit of time. The other thing it does is if you're the engineer, you kind of have knowledge of how that part maybe explodes, right? But marketing may not. So you can actually create that entire exploded view inside of SOLIDWORKS, and then marketing can take that and run with it. So we're going to go ahead and open this guy up. And what you'll see is as soon as we open it, we basically have all of our views right here on the views pane. So kind of a starting point, at least some data to get us going. What I would like to do is create an animated explode of this particular component. Now, an easy way to do this in Composer is I can basically go down to my animation timeline, drag it over to a specific point, and I can just start adding views. Hey, this is what I want my video to look like at this point. Move it a little farther. This is what I want my video to look like at this point. And then when I hit play, SOLIDWORKS basically interpolates all the different positions of those components, and it makes the video all based on 2 images. Okay? I am not good at making videos. That's why we have Marcus, right? But even I can do this. I can grab a couple pictures and just drop them around on a timeline. Now, when you want to go and save out this animation, what you can do is you can go over to your workshop and you can go to your video workshop. And when you hit Save As, we've got a new option here for file types. So in the past, the only thing that we could save out was basically AVI files. And while those serve a lot of purposes, a lot of people wanted additional file formats. So now we've got the option to save out as FLV, MKV, and MP4, which is kind of the big one that a lot of you guys asked for. So if you're currently using Composer and you're just looking for a different way to export, check out the option for exporting to those new file formats. All right, now animations are really good, but images still serve a big purpose. And one of the things that I've noticed, because I do a lot of Amazon shopping, is pretty much everybody seems to have like 360-degree views of their product. You can go through and basically see it from every angle, so you know you're buying the right thing. We can now do that a little bit easier in Composer. So in Composer, all I've really got to do if I want to make a 360-degree capture of a component is basically choose the view I want, orient that view in a specific orientation, and then I'm going to go up to my high resolution image workshop, and on the multiple tab, we've now got an option for 360 capture. Okay? So all I've got to do here is say, hey, I want 25 pictures captured around a 360-degree circle. Composer's going to do the rest. So I've got kind of an example here that I saved out that I'll show you guys. And you can basically see if I open up one of these images, I can really quickly just cycle through all of the different orientations. If you tried to do this in Composer in the past, you could do it, but that required you to basically manually move the camera around. So it was kind of a lot of steps just to grab all those quick images. Here, in just a couple seconds, I can go ahead and grab all those 360 captures. So again, if you guys are part of the team that's currently making all of those technical documentations, you're not using Composer and looking for a more efficient way to capture all those images, check out SolidWorks Composer. All right, how many of you guys make plastic parts of any type? Injection molded, right? All right, we've got a tool called SolidWorks Plastics. You guys may or may not be doing your injection molding in-house, but SolidWorks Plastics allows you to simulate the injection molding process. So basically what that means, if I've designed a part that's going to be injection molded and I want to make sure that we've set up this mold correctly, I can basically simulate how material will flow into that mold, and I can see if I'm going to have short shots, shrinkage, if I'm going to have warpage, all this stuff that nobody wants. All right, so what I want to show you guys is just a little way that we've enhanced SolidWorks Plastics that I think makes it a lot more efficient. So to start off with, what we're going to do is we're going to create a new SolidWorks Plastics study. So I'm just going to go create a new study, and then I'm going to start to do a little bit of setup work. Now, I am not a simulation guy. I've got Roland for that. Man, the one compliment I give him, he's not even in here. Oh, all right. I've got Roland for that. Roland knows simulation a little bit better than I do. I'll give him that one. And basically, I like to do a little bit of the setup work so that once I send this over to Roland and he's actually going to run the study, he really doesn't have to waste a lot of time with the setup. I've kind of done some of that for him. So the first thing that I need to do is I need to define domains. Domains are basically saying, hey, these are the different parts that I've got in this assembly. So I'm going to start off by just applying a domain here and specifying that a specific body is actually the cavity for this setup. I can then go and basically specify that another component's the insert. We've also got our two mold halves, our cooling channels. And what this does is it allows me to basically specify the different ways that we're going to simulate some of these parts. The nice thing about this, and basically the biggest update that you're seeing here for 2020 that wasn't available before, is I can actually do all of this before I actually mesh this study. I'll show you another way that we can do this through boundary conditions. So I'm going to hide a little bit of geometry here and show you guys some SolidWorks Plastics boundary conditions. All you're seeing here, this is basically the actual part that we're going to be molding, and then we've got a couple of cooling channels. And what I can do is I can set boundary conditions like my injection location. Okay, I can go and specify the exact point on this part we're actually going to be injecting material. Now, for some of you guys that either don't do plastics or haven't run a study before, this may not seem that crazy, but meshing a SolidWorks Plastics simulation or any injection molding simulation is actually pretty complex. There's a lot of variables. It takes a little while to set up. So the fact that I can actually do this ahead of time, in my example, I can save Roland a little bit of work. I can specify all this stuff. I'm smart enough to do that. I'll let him handle the meshing and some of the more advanced parameters, but I can do this all ahead of time. So just a more efficient way to work in plastics. How many of you guys do any sort of machining in-house? A couple of you guys? All right. How many of you guys are using SolidWorks CAM? Anybody? All right, we got a couple SolidWorks CAM users. So a couple years ago, we introduced SolidWorks CAM. SolidWorks CAM was kind of an introductory option for people who are looking to get started either machining on 2.5 axes, or maybe they were looking to do some lathe work as well. Now, SOLIDWORKS CAM has seen a couple of advancements over the years, and what I want to show you guys is a new one with an example from the Omax water jet. Here I've got a big piece of plate, right? Now, those 3 circles there, those are actually vent holes for a fan. So what I want you guys to do is picture this plate sitting on a water jet bed, and we're actually cutting out all those circles, and we complete the circle. What happens to the material in the middle, right? Probably sinks to the bottom of our water jet, right? So if we're basically cutting out those circles and the material's falling away and it's sinking into our water jet, we're not going to see it again for maybe a year or 2, depending on how much cutting we do when we go to clean out that water jet. So another option that we've got where SOLIDWORKS CAM can help out is a new option called tabs. So what I'm going to do here is I'm going to actually edit the machine, or the toolpath rather, for cutting out those circles. And on the contours tab, I've got a new tab cutting setting. So what I want to do is I want to leave a little piece of material, right? I don't want it to quite break free all the way and sink to the bottom of that water jet. All I want to have to do is come by with a torch or some snips and just snip it off. That way I don't have to worry about that stock falling away. So I'm going to go set up a couple tabs, and basically what I can do here is I can specify the number of tabs that I want to have. I can specify the length of all the tabs, and I can even adjust each tab individually if I need to. Once I hit OK, all I've got to do is just save my changes, and then we can actually go simulate this toolpath to see exactly what it's going to do. All right, so let's go ahead and play that toolpath. And what you can see here is all of these little instances where it basically skipped over and it left a little piece of material hanging on. This is really, really important. It's just one of those extra features that's going to prevent you guys from losing stock. It's going to prevent you from maybe damaging your machine if a piece of stock falls or damaging your part. Just one more little enhancement inside of SOLIDWORKS CAM. Now, if you're doing something a little more advanced than cutting out some flat plate or doing 2.5 axis milling, what you really need to do is go talk to Brian Johnson over here by the door, looking to make his escape. But Brian Johnson's our Mastercam guy. He's been around in DFW for quite a while. Most of you guys probably already know him. But Mastercam is the solution for high-speed multi-axis machining. So if you're looking to make the most efficient tool pass and machining operations possible, go talk to Brian. He can tell you guys all about Mastercam, talk with you guys about what you're currently doing and how we may have some solutions for you as well.